Okay, so for the week 6 discussion, we are looking at wage data to see if there's some information in this data set that can tell us if we can increase our wage, maybe with the number of years of education or the number of years of experience that we have. So let's get started. Okay, the first thing I like to do here is, like you've seen in my other videos, I like to go ahead and name our outcome variable or the dependent variable. So we're looking at how can we increase wage. And then our independent variables, in this situation, we're looking specifically at education, which we'll actually call that Y instead of an independent variable, but that's it. The independent variables or the predictor variables, those are X. And we're also looking at experience. Now, I can't do a regression analysis with this chart because all the columns are spread out too much. So I have some options. I can either just delete these. You can right click and hit delete, or we could move some things around. So I'll just move them around because later what I'd like to do is actually run a test with all the variables to see if there's a relationship between any of these others. But let's just start with the first two, which are going to be education and experience. Okay, so now I've got the table looking right. We've got education and experience side by side, and we're trying to predict the wage. So let's go into data analysis, regression, and in your top box, that's your Y range. So we know that Y now, because I labeled it, is A. So go ahead and click on the name and then highlight the rest of the column. We're going to click on labels, make sure that's clicked. And then we want to do the X range. Now, if your variables are side by side like ours are, you can highlight both B and C. You don't want that first row. That's just for our own knowledge, but go ahead and put B and C as far as education and experience and all the data there. And we're gonna, like I said, have labels, and we'll leave the rest as is. But let's put our output range. Let's come back up here and put our output range on the same spreadsheet this time. We'll just stick it right here. So output range, and then tell it where you want it. All right, now you can see the output range, and this is helpful. So we can go back and forth between the spreadsheet. Now on this, we have several, lots of information, but the ones that we're mostly concerned with are R-squared and adjusted R-squared. We are also concerned with the coefficients, the significance F, which is your p-value of the overall model, and then your p-value here for each independent variable. Now our p-value, if you'll notice quickly, this is too big. We want it to be 0.05 or less, and this one is much bigger than 0.05. So this model by itself doesn't work. However, if I look down here at these p-values, now the intercept, that's our constant, so that's it by itself, and we're not looking at that, but for the education and experience might by itself. So what we could do is remove education and try this again. So let's do that. Let's go ahead and come back in here. We will do data analysis, regression. Now, instead of both of those X variables or predictor variables, we're going to only look at experience. So we'll do experience. And then this time we want the chart to come down here so that we can see it below. All right, here we go. So now this one just has experience, and this one's looking, well, a little bit better, but not entirely. The p-value is still above 0.05. So this is why I wanted to include everything in the data set. So let's go ahead now, come back over here. This time we're going to include the rest of this and see what's going on. So let's go to data analysis, regression, hit OK, Now this time we're going to do the X range. We're going to just include all of this because we just don't know what's going on. And then our output range, let's just go ahead and put it on a new worksheet to clean this up. Okay, now the p-value is still very big here. And this is part of the process. You have to play with the data to see what's going on. But if I look at the p-values down here, I can see that experience by itself still appears to be maybe related, and female may be related. The rest of these are above 0.05. So we're going to run this one more time. So I'm actually going to call this model 1 because it's got everything in it. This time we're going to do it, I'm going to call it model 2. So let's go back to data analysis, regression. This time though, actually, this is where we need to make some decisions here. So instead of education, we want experience and female. So let's pull this over to a new spreadsheet. We'll take out education and we just want female. So we're going to have 2 of these and wage. Now that it's cleaned up quite a bit, regression, this time we want experience and female. Okay, I think we have something. All right, so the multiple R in this situation is telling you that roughly, let's see, I'm sorry, the R squared, roughly 13% of the variability in wage can be explained with the independent variables. Now let's take a look at the independent variables again real quick to see what the p-value is doing. Because maybe, although this shows significance with the p-value here, this is still causing some issues. So experience just isn't going to cut it. So let's just get rid of that. All right, let's do this one more time. We're going to do, actually we could do it on this tab. We'll just get rid of experience. Now we're going to go into data analysis, regression, and this time we're just going to look at female. Okay. All right. Now, looking at R squared and adjusted R squared, we can see that, well, maybe 13% of this model can explain the variability. So it's not huge at all. Actually, I need to hit this button. So 13% of the variability between wage and gender is explained with this model. The adjusted R square just adjusts for the sample size and also adjusts if you have multiple independent variables. In this case, we only have 1. But either way, 13% or 12% is pretty low. We have observations, we only have 100, so that could be part of the problem. It's just not a huge sample size. This is also referred to as N for number of participants in the study. Now your significance though, this does show that there is some statistical significance. We want our alpha to be 0.05 or less. It's definitely 0.05 or less. And then if we look down here at this alpha for the p-value, it is also 0.05 or less. In fact, it's the same thing if we come in here. So it's 0.00027. So this does show significance that gender has a relationship and can predict wage. But what does it do? So in order to predict, we need to figure out what this coefficient is telling us. And in this case, it's telling us that if the, let's go back to the data so I can show you, because we have female 0 or female 1. This is kind of named funny. I would actually name it gender. 0 is probably male and 1 is female. That's usually how that goes. So 0 being male, 1 being female. And then in this case, let's get back over here. So if you're female, you're making about $12,000 less per year than the men. And that's what this is telling us. So if we want to put this actually in a predictive type document, let's just take the wage that we have here. And I think it's this one. Yep. So here we have the wages. Oh, copy and paste. So here we have the wages. We'll make that a $sign. And then unfortunately, so let's say this is the overall wage, and then we're going to subtract this $12,041.41. This is the amount that we will subtract. So that's the prediction. And that is in the red. So that's a negative. So then we're saying that females, in fact, we could just go ahead and name this, let's say males. And if it's a female employee, then we're going to say they make $12,000 less. Oop, that didn't work. So equals 19. And then I already have the negative there. So there we go. So that's what it's telling us. Then we have we are making less money, less money than the men. So this, let's go ahead and get this in here right. Excel will oftentimes try and put some logic in for us, but we just want this amount to stay the same. There we go. So let's say somebody's making $83,000. Maybe the ladies are making $71,000 instead. So as far as your prediction, that's what we come up with. Now, again, as a recap, we tried several different models with this. We first looked at, because the document told us to look at education and experience, but we found that that p-value was too high. So then we looked at experience by itself. That was too high. So we went over to a model with everything, still a big p-value, but we saw that the females had a higher or a better alpha, as well as experience still showed a little bit of a decent alpha here, but this number is really the driver, this significance value here. If this is above 0.05, we don't even need to look below here. So what we did then is we took female and experience and pulled those apart so that we could look at them by themselves, and that's where we found, let's find the right document here. That's where we found that if we look at only female and experience, the model was statistically significant. However, experience was still not good. Their p-value was too high. So that tells us that only the gender was significant with this data set. And then that is where we pulled in gender all by itself, looking at females versus males and finding that the ladies were making less money. So then we could predict that regardless of what the men make, the ladies are probably making about $12,000 less each year. All right, I hope that helps you, and I'm looking forward to seeing your assignments.